Today we're going to continue our work with inequalities. And what we're going to be doing today is instead of just graphing a single inequality on our coordinate grid, we are going to kind of work on what we did with systems of equations, where we looked for systems of equations, we looked for the spot where two lines intersected, and that was a ordered pair. Today we're going to have our solution for our systems of equation be the spot where the two graphs overlap, where they're double shaded. So that's what we're going to be working through today. So we're going to be graphing two inequalities on a single coordinate grid. Let's go ahead and jump on in and get to work. So let's go ahead. We are working with systems of inequalities. So, example number 1. Our first line that we're going to be graphing, our first inequality, is y is less than negative 1/2 plus 4. And our second one is going to be y is less than or equal to 3x minus 2. So once again, y is greater than negative 1/2 plus 4, and y is less than or equal to 3x minus 2. So let's go ahead and walk through what those steps are going to look like. So step 1 is to graph the first inequality. And for additional notes on how to do that, those are our notes from our class last week. So we're going to go ahead and take a look at our graph. And first we're going to go ahead and pull out our y-intercept. And our y-intercept in this case is a positive 4. So we are going to make a dot on our y-axis at 4. Okay. The next piece of information that we need is to move our slope. So here is our slope. Oh, we forgot our x in our equation. There we go. Negative 1/2 x plus 4. That's an important part. And so our slope is negative 1/2. So the negative 1 tells us we're going to go down 1, and then the 2 in our denominator tells us we're going to move 2 to the right. So from this spot, we're going to go down 1 and 2 to the right. Down 1, 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 2 to the right. I also like to continue in the other direction. We're flipping a 180, and we're going to flip both of our arrows. So we're going to go up 1 and 2 to the left. Up 1, 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 2 to the left. Once again, you can very quickly see if you did that swapping incorrectly because your line kind of go all wonky on it. Okay, now we go ahead and we look at our inequality itself. It's greater than. So our greater than tells us it's going to be a dashed line, and greater than means we're going to be shading above. Okay, so we're going to use our ruler. Always use your ruler. And we are going to do a dashed line. We're going to put our arrows at the end of both edges. Our next period class is beginning. And then we're going to go ahead and shade above. Remember, we're not scribbling, we're shading. And we're just going around those boundaries, and then we're going to fill in the middle, doing a nice shading. Okay, and this is what we learned last week, is how to shade and graph a single inequality. Okay, at this point, we can test a point in that inequality. We know that 0, 0 should make a false statement. So 0 is greater than 0 plus 4. 0 is greater than 4. 0 is not greater than 4. That way we know that this side should not be shaded. So we know that we shaded the correct side. Okay, step number 2 is graph the second inequality. Okay, so once again, we're going to take this and we're going to pull out our y-intercept to start with. And we're going to plot that. So our y-intercept is -2. So we're going to go ahead and put a dot at -2. And then we're going to go ahead and take our slope, which is 3. Because it is an integer, we need to turn it into a fraction. So we write over 1. And we're going to go up 3 and 1 to the right. So from this point, we're going to go up 3 and 1 to the right. 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 We're going to go ahead and do the same going the other direction. So we're going to go down 3 and 1 to the left. Down 3, 1 to the left. Down 3, 1 to the left. Okay. Now we're going to look at our sign. We have a less than equal to. So this is going to be a solid line, and less than is going to be shaded below. Okay. So we're going to draw our line. Solid line because that equal to is there. And then we're going to go ahead and add our arrows on both ends, and we're going to shade below. Remember, if you're not quite sure, we kind of pretend to put a weight on there, and we see that the below would be on this side. And so now we're going to go ahead and shade nicely, not scribbling. Below that mark. Okay. Step number 3. Well, this is still part of step number 2. We're going to test that 0, 0 point again. Once again, 0, 0 should make this equation false. So 0 is less than or equal to 0 minus 2. 0 is less than -2. That is false. 0 is greater than -2, so that part should not be shaded. Step number 3 is outline the solution. Now, your solution in this case is where your area is double shaded. So your solution is where your area is double shaded. So you can outline that to make it a little bit more strong. I'm going to outline mine in green here. And so remember that this is going to continue forever in all those directions. Everything that's on this line, because it's solid, is a part of the solution and is going to make both those equations true. Everything that is on this dashed line here is not a part of the solution. So the items that are on this dashed line are not a part of the solution, but the answers on the solid line are. Now, your final step number 4, and I recommend that you do this, is to check on Desmos. Okay, a lot of times in our Desmos activity, I have that ready for you to check, but we're going to go ahead and make sure that we are going to have that correct answer, the correct one shaded. So you're just going to go onto your Desmos calculator and type in those inequalities. Y is greater than -1/2 x plus 4. Okay, this is our first line. Our second one here, y is less than, we type in less than, and then on your keyboard, you're just going to type the equal sign, and that's going to automatically put that equal underneath 3x minus 2. Okay. So as you can tell, as you're comparing that to your graph, you can see the solid lines, the boundary lines, and those areas that are double shaded. Okay. So let's go ahead and try one more example. So here is our example 2. We're going to have y is greater than x squared plus 2x minus 8, and y is less than or equal to 2x minus 3. Now, as soon as I wrote this problem down, your brain should have kind of went, burr, burr, burr. And that happened as soon as you saw that x squared. Now, when you see that x squared, you should automatically think, oh my gosh, it's x squared, it's a parabola. So for this second one, we're actually going to be graphing and shading an inequality that surrounds a parabola. So we're going to go ahead and deal with this first equation first. Now, the way that we're going to find our parabola is we are going to do a generic rectangle diamond problem, and we are going to find our intercepts, and we're going to find our vertex. So let's analyze that. Our A is 1. It's the number in front of our x squared. Our B is 2, and our C is negative 8. We're going to go ahead and multiply A times C for the top of our diamond problem, so negative 8 at the top, and our B goes down below. So we're looking for two numbers that multiply to be negative 8 and add to be 2. So we have 1 times 8, which adds to 9, subtracts to 7. That doesn't work. We're looking for a 2. We have 2 times 4, which adds to 6, subtracts to 2. Ding, ding, ding. That's what we're looking for. So we have a 2 and a 4. Now, to make it a 2, we're going to have to go 4 minus 2. Okay? Now we're going to go ahead and take our equation and we're going to put it inside of our generic rectangle. Our x squared goes in the bottom left. Our constant goes in the upper right. And we broke up our 2x into our right and the left, a negative 2x and a 4x. Now we're going to solve the outside of our problem. X squared is x times x. X times 4 gives me 4x. And x times negative 2 gives me negative 2x. I'm now going to write that in product form. X plus 4 times x minus 2. And we're going to use the zero product property to solve for my roots. So x plus 4 equals 0, and x minus 2 is equal to 0. I'm going to subtract 4 from both sides. And my first root is going to be at negative 4. I'm going to add 2 to both sides. And my second root is going to be at positive 2. So now we're going to go ahead and plot those roots onto my graph. So I have a root at negative 4, and I have a root at 2. Now I'm going to go ahead and find the vertex. So once again, I'm going to add them together and divide by 2, or because I'm graphing it, I can kind of just go boink, 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 and find the middle of it because it's symmetrical. So I know that my x value is going to be negative 1. Now, once again, if I wanted to do this mathematically, I would go negative 4 plus 2 all divided by 2. Negative 2 divided by 2 gives me that positive 1. Now that I have that positive 1, I need to know the y value. So I'm going to plug that either into my original equation or into my product form. I personally prefer to plug it into my product form because I'm less likely to make an error. Negative 1 plus 4 is 3. And negative 1 minus 2 is negative 3. Negative 3 times positive 3 is negative 9. And that is my vertex. So I'm going to go ahead and plot my vertex at negative 1, negative 9. Now I have my bonus point of my y-intercept, which is always my constant. So I can go ahead and put my bonus point here. Now my bonus point is 1 to the right of my vertex. So I know I can have, because once again it's symmetrical, 1 more to the left of that. Okay. Now it's time to analyze this greater than. Greater than tells me it's going to be a dashed line, and greater than tells me I'm going to shade above. Now, that doesn't work as well as with lines. So let's go ahead and start by doing my parabola itself. So once again, you're doing a dashed parabola. There we go. Arrows on both ends. Now, which is above, which is below? Well, if you kind of think about it, right, our inside's going to be above our vertex and the outside's going to be below. This is really confusing for some people, so I always just use my trick of checking 0, 0 to see if it makes a true or false statement. So if I do that for this equation, 0 is greater than 0 plus 0 minus 8. And I ask myself, is 0 greater than negative 8? And that is yes. So my answer yes means that 0, 0 should be shaded. So I'm going to go ahead and shade the inside of my parabola. Once again, take your time. Don't scribble. And remember, it continues forever and forever above my graph as well. But it is contained inside of this parabola. So we can do this with any shape, test a point, and then decide where our inequality is going to lie. Okay? Now we're going to go ahead and jump into our second here. And this, of course, is back to what we've been working on mostly this chapter, which is lines. My y-intercept is negative 3. So once again, my plane number is my y-intercept. So I'm going to put a dot at negative 3. My slope in this case is positive 2. Once again, we're going to need to change this into a fraction. So it's going to be 2 over 1. The 2 is positive, so I'm going to go up 2. The 1 is positive, so I'm going to go 1 to the right. So from this dot, I'm going to go up 2, 1 to the right. Continue that pattern, up 2, 1 to the right, 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 up 2, 1 to the right. And then I'm going to reverse them both to continue going the other direction, down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left. Now it's time to analyze. I have a less than equal to. And the equal to tells me it's going to be a solid line. And the less than means I'm going to shade below. Once again, it's a little easier to tell in your line. So we're going to go ahead and line up. And we're going to make a solid line. And then we're going to go ahead and shade below. Now remember, anything on a dashed line is not a part of a solution. And remember, these are going to continue forever. And anything next to a solid line for your ordered pair that you're looking at is a part of the solution. Okay, like I said, I like to outline the area that is the solution. A different color here. So everything on this line is going to be part of the solution. Everything on the edges of the parabola is not going to be a part of the solution. Right? And so this right here, ladies and gentlemen, is my second system of equations. So it's not always two lines. Sometimes it's a line and a parabola. Sometimes it's two parabolas, but we follow the same basic rules. We're going to finish up by checking on Desmos that we did that correctly. So our parabola was y is greater than x squared plus 2x minus 8. Go so we can see the whole thing there. And our line was y is less than, and once again, once you have that less than, press the equal sign, it'll go underneath 2x minus 3. Okay, so as you can see, it looks very close to our graph that we had, and you can see that this area right here, everything on this line is a part of the answer. Everything on the dashed part of the parabola makes the inequality false. Okay, ladies and gentlemen, go ahead and staple those in your notebook, and let's go ahead and practice and do a lot of graphing once again on our Desmos daily activity.